It's about 10:05 now, so I think I might start. So, I've called this Writing a Framework for Fun and Profit. Arvind asked me to do this session as a sort of masterclass for how to write reusable code, and we talked about toolkits and frameworks, and really the fun stuff, I think, is in the frameworks. So who am I? I'm James. Hello. Hi. I've been doing this for 10 plus years in the industry. I've been writing code for 100 years, and that's some of the things I've done. So, what are we going to be talking about today? Frameworks, libraries, toolkits, whatever. You can't see it if I walk in front of you. But why should you care? So I'll talk about that for a little bit, and then a few subjects which I'm not going to read out because you can read too. So, why should you care? What this isn't. It's nothing to do with a specific technology, so I'm not going to be showing any code today. That might be disappointing to some, but I think as you get higher and better, sort of code becomes much less relevant. It's more about the concept behind the code, because syntax just is syntax. And somebody asked me what my talk was about, and they said, oh, it's just going to be about encapsulation, isn't it? And no, it's not going to be just about encapsulation, although that is important. I'm not promising to be exhaustive about anything in particular. I'm really just going to be telling you 3 or 4 things which have really sort of smacked me on the side of the head, insights which have really sort of changed the way I code, changed the way I design, and ultimately led me to where I am now. Okay, so why should you care? Why would you want to write a framework? Well, that's a good question. Thanks, James, for asking that question. Let's click yeah. Okay, it's infrared. Oh, wow. So, Microsoft, back in the day, had this really interesting split in how they organized their development teams. They had these sets of engineers who they called tool makers, and they were the guys who wrote the UI toolkits, the embeddable OLEs. I'm not entirely sure about the Microsoft stack. And then you had the sort of the people who they considered sort of slightly less strong, who would use the tools that the tool makers had made to actually build the applications that you guys and me used for so long. So, as a framework developer, you are definitely in that tool maker camp rather than tool user. And I guess if you're building websites, you're going to be using a framework, which means that you're going to be the tool user. So, to be a bit more graphic, this is how, when I was working in operations, I made a prediction about, which really prompted me to get out of operations, which is, operations is going to be something which is the equivalent of a car mechanic. It's skilled, but it's not very, there's not much status to it, and there's not many prospects to it. And this is how I see the tool users, sort of the people using Ruby on Rails, the people using J2E, the people using, not to disrespect anybody, but actually they're going to end up like this. Whereas what you might be interested in being is the architect who's designing the house that builder was building. This is an architect, and he's gazing at a model of the Lord Mayor of London's new office, or it was new about a decade ago. And that's what other people think of you. This is what happens at work. So this is a set of primary school rules that little kids get taught, and this is how your boss will probably see you. And in contrast, being a tool maker, I think you end up, oh dear. No, I'm going to give up on this. So this is the primary school rules. And this is, if you're writing frameworks, this is how your peers and your bosses see you. Sort of writing amazing, cool stuff that nobody quite understands except you. Or your team understand. So the work becomes a lot more interesting. And when I sort of think about how I feel when I'm doing these things, I'm feeling as though when I was just sort of following the rules and going through the motions, then I felt a bit like this soldier ant, this leafcutter ant, who's essentially just doing the same thing every day and marching in procession in tune, and feeling quite sort of like an automata. But I contrast that with how I feel when I'm writing the cool stuff that I write and I want to write, and I feel much more like this. So, okay, so nobody's walked out yet. That's good, because this is a powerful picture, I think. So the first thing that I'm going to talk about is this, which is when I have new juniors and when I start mentoring a new developer, this is the thing that I drum into them most, this word-shaped thought. This isn't specific to writing frameworks or writing tools, but it kind of underpins things so much, and I feel this is really so important. I don't know who noticed it first. I feel like I found it on my own, but I'm sure I'm not original. There's bags of philosophy behind thought and language. So I'm going to unpack that a little bit. So word-shaped thought. So when I'm writing code, I try and find a language for the concepts that I'm trying to express. The concepts will be the solution to the problem, or it's a method of solving the problem. And I sort of write it down in English, or maybe I'm talking about it in my head in English. And then I start breaking those concepts and breaking that language down into nouns and verbs and see really whether I can express it a bit more clearly. And the granularity of my thought becomes narrower and narrower, so I'm actually thinking in terms of solving the sub-problems which make up the larger problems. I'm still using the nouns and the verbs which I've started using with these concepts. And this is where I think the really interesting thing happen, is that you make this code, your code, that you actually write the code in terms of that language that you started. So using the identifiers, so the class names will be meaningful in the language that you've just been talking about, or the variable names or the method names, and you sort of build the code up from the very small granular level to the sort of larger systems, and really, yeah, I feel really strongly about this. So one of the things that I've been sort of also the gotcha about this is using overgeneral method names or identifiers. So these guys here, I pretty much ban. Anybody saying process, having a method called process, process what? Process, apply, execute. They become so general that they lose any meaning at all. And I write double plus ungood. Does anybody recognize that? Double plus ungood. Yeah. Okay. Any references? Who said that? Good man. So yeah, it's a Newspeak joke, because the whole point of Newspeak was to make things overgeneral and sort of kills thought and stops you expressing ideas very well, because you lose all vocabulary to express nuanced ideas. So this idea of overgeneralizing is really trying to get out of that trap. And the consequence of choosing the wrong words, choosing not sort of matching your concepts in your language, in your code, you get out of sync and you end up in a sort of doublethink situation, which is where you have to hold two maybe conflicting ideas in your head at once, which is really a very difficult thing to do. And yeah, I mean, doublethink's another Newspeak thing. So why this matters? I think I've sort of gestured at it, but these are, I think, what really I've come up with, which is the sort of thought to code gap. What a horrible concept. What a horrible expression. But you can think about the code in your head in the sort of pictures and words that you might use when you're thinking about design, and then look at the code, and it's very much more clearly expressed in those terms. And you have a more readable code because of it. And because you've got this, you've pretty much been talking about a shared language within your team. So suddenly your code becomes easier to talk about. Again, a horrible term, intra-team communication. But it's true. And bugs, I've talked about bugs being harder to write because they are. I mean, it's not just because the code is easier to test. You're writing bottom up and you can see but actually you can read statements and read methods and go, hang on, that doesn't fit the way I'm thinking. So bugs are actually harder to write, like the first time rather than second time when you've tested it. Now, as I say, it's not a new idea. I feel like it's mine, but it's not. You can talk about patterns. Who's come across? Oh, we've all come across Gang of Four, right? The pattern book. Okay. Yeah, is that? Who hasn't? You guys are awesome. And the point of patterns is that it provides a shared language, or it provides a vocabulary for you to talk about software design. And so that's the second point here. But over the years, I've found that I'm using little languages more. I'm sort of exposing the power of those other people's little languages, so SQL, XPath, and ultimately JavaScript as well, to sort of let the user surprise me, let the application developer surprise me by using these languages which I haven't needed to code, but they sort of know what to do with. And you can see this in sort of games using scripting languages. So Lua is a very popular scripting language for games. And yeah, I won't belabor the point too much. Okay, so now I've talked about the importance of words. I'll just go back to this idea of frameworks versus toolkits. I'll be honest with you, I'm not sure what the definitive answer of what the difference between a framework and a toolkit is. We can argue about it later on, but I can probably come up with counterexamples to whatever rule you come up with. But the sort of working one that I use is what's called the Hollywood principle, which is don't call us, we'll call you. So if you've got a bit of code which you sort of put into the toolkit or into the library, and I'm not talking about callbacks, I'm talking about sort of almost plug-in type things, where, say, a servlet container is going to be called back by the application framework, the application server, and that's definitely the application server calling the application code, the servlet. So that would be a framework. But something like, I don't know, let's say jQuery, that would be a toolkit, I expect. Ultimately, it's a very fuzzy, hazy definition, and it's not that interesting, but I thought I'd just talk about it right now. So that's the first thing that I wanted to talk about. So I've just mentioned plugins. I spent quite a lot of time using OSGI and Eclipse and writing Eclipse plugins and writing OSGI bundles and sort of messing around with NetBeans plugins, and it was all cool. But one thing it really helped me with was this idea of starting your framework or starting any piece of code with a plugin system already there, you know, with life cycles and discovery of new plugins. And it really changed the way I thought about writing code. So a plugin system, I mean, plugins provide a sort of modularity above the package layer. And it's about sort of a self-contained bit of code talking with a well-defined API to your framework, and maybe other plugins. And the thing that's sort of really interesting is writing. I mean, we're all Android or iOS devs, and neither of those systems have a plugin system. But if you write your code or your framework that's running in that code as if you've got a plugin system, so you just have a sort of a simple add plugin or add extension or whatever. That helps you do the same sort of thing of having that package above the package modularity in it and smaller APIs. So yeah. So I'm going to talk about these guys here, which is straight from the Contributing to Eclipse book by Eric Gamma. Gamma is the guy who wrote the Patterns book, actually, or he was one of the Gang of Four. And he talks about these rules for contributors, rules for enablers, rules for maintainers. Oh, well, I forget what are the other ones, but I read these guys, and there's about 10 of them, but I've outlined about 6, I think, here. And the top 2, the first one seems pretty obvious in an Eclipse setting, but for if you're not in an Eclipse setting, it's holy shit. We let people contribute to you. That's the sort of explicit build a framework, let people add code to your code, and you've got to deal with that somehow. And it's the second one which is literally overnight changed the way I thought about code, which is all clients play by the same rules, even me. So that's the idea of, okay, so I've got this framework, whatever it is, this plugin system, and I'm going to build a framework to do something. Sorry, using abstract, overgeneral words there. But in order to achieve the stuff that I want to do, I've got to play by the same rules as the people who are going to be contributing to my framework. That sounds all very woolly, but does that make sense? Yeah? Cool. And a sort of couple of rules about that small API, that small well-defined API, was that you separate the API and you sort of document the API and you make it sort of really obvious, and then the implementation of that API you hide away, and the clients, the plugins, just don't need to know about it, and you say here be dragons and please don't come in here because it'll change, or it might not change, or it's particularly horrible. I don't want to expose this stuff to you guys because this is my cellar with a door which I lock and I don't want you to go into. And this point of contributions and plugins and extensions and what have you is really about sort of encouraging participation. So you can have lots of teams who don't know about each other playing all in the same sandbox, and when they're ready, everybody sort of comes together and very disorganized, not disorganized, but uncoordinated. But more importantly, for your day-to-day life, I mean, that's for writing big open source projects, but requirements change and new features get added, and you really want to be sort of locking down the stuff that works and then just changing the stuff that needs to be changed, rather than sort of this wallpaper, bubbles under a wallpaper thing where you've got a bubble and you have to press things down here and the bubble just moves over here and it's really ugly, and you end up driving yourself nuts because of it. And I'm sort of struggling to come up with this term, and I've got this other word which is containment of unpredictability. So you're giving a sort of framework where people can extend stuff and they don't interfere with one another, or they interfere with one another in sort of fairly well-reasoned ways. And so I'm going to try and give you an example of that, of what I mean, because it's fairly easy to write a plugin for whatever plugin system, but when you've got a plugin system, how do you deal with that? And I'm just going to talk about this idea of you've got these plugins or extensions, and you want to put them all together, and how do you put them all together in a way which kind of makes sense? So I've come up with a very simple real-world example. I hope it makes sense. So these are my requirements. I've got a street. I'm a town planner, and there are houses that are going to be built on it. Maybe I know the order of the house is going to be built, maybe they're not. But the question that we're going to solve today, or going to look at today, is how do we number those houses? So this might be I don't know, there might be something cultural here, or maybe I'm just being stupid, but I haven't worked out how house numbers work in Bangalore. But we'll talk about that maybe later. So solution 1 came up with this, which is we've got these numbers here, and we start off with 1 and we go all the way up over to the end, and then once we've got to the end we come back and sorry, I should use my shadow here. No, I can't. So, and we get to the end of the house, the street, and then we start again either at the same end or the other end, and we just go and we sort of go in rows like this. And that sounds really simple, and that's that brain-dead first cut that may actually work or may not work. But it's not very extendable, because what happens where do I put house number 9? I can't see where to put house number 9 either. Maybe after house number 8, but then you sort of break that symmetry and you get long rows and short rows, and it just feels weird. And if you're a taxi driver and somebody says you need to go to number 7 or number 8, which end do you go to? Do you go to the left-hand way or the right-hand way? And of course, it requires a lot of local knowledge, and taxi drivers really earn their money at that stage. So it's not very navigable either. And I think, did I say that? You kind of have to know how many houses you've got and when they're going to be built, and in order to have any kind of sensible ordering system. There are examples in the town that I live, Brighton in the UK, where this happens. Very old streets. This is far more common in the UK, where you sort of have all the evens on one side and all the odds on the other. And this is kind of the dominant way that things happen in the UK, which is so you end up with streets that you can start at one end and keep building until you run out of street space. There's no limit apart from space about how many houses you can put in. But it's extendable only in one direction, and it assumes that all the houses are roughly the same size, or equal sized, and it assumes that there's no space between the houses, which sometimes you want space between the houses. Maybe there's a playing field or a hospital or a street or something, airport. So this is kind of practical if you're building houses in the UK. This last one, which is, this is how they do it in rural Canada and some parts of Australia, where they start off with, they have this enormously great long road where, say, between Adelaide and Melbourne, and then they number the houses based on how far it is from one end. So you can see that this first one on the left is 103 kilometres from the start, and the one on the far right is 190 kilometres, because it depends on how many tens of metres you are away from the one end. Now that's kind of neat. It's navigable, as in you just need to know how far you've driven or how far you've walked to get to an address. But most importantly for me is that you don't have to know up front what order you're going to build your houses in. So, 15705 might have been built, the original house on the single road, and then everything else can happen either side of it. Out of order, doesn't really matter how, any which way how it's built, and also you don't have any restrictions on size of the house. So that's two really important things, that you can have big houses and little houses, and you can build them in any order. So coming back to plugins or your extensions or whatever, you can load them in any order, and there's no sort of ordering, which it's always going to be troublesome. If you can get rid of that order dependence, that's a real win. And of course, you get metaphorically big plugins and metaphorically small plugins, and you don't have to have a set thing. Now, that's cool. Let's keep going. So, I think this is the last thing I'm going to talk to you about before we start opening up the floor and talking. And this is another powerful idea which I've come across, which is UX for developers. This isn't how to get developers to do user experience. This is developers are people. Developers are users. Now, if you're a tool maker, how do you make the life of the users of your tool better? How do you not make them swear about you or hate you? Now, there's quite a lot to be said about this, and I've only got about 3 slides to say it in. Well, to begin to say it in. But essentially, it's the whole discipline of user experience, user interaction design, and user-centered design, and really transposing it into, instead of products, Instagram, Facebook, whatever, into frameworks and APIs and toolkits. So, you've probably heard this principle of least surprise, but it pretty much it starts off there, or this everything should be obvious. Principle of least surprise, and it's really about every roadblock is a really good excuse for the developer, the application developer, not to use your framework. So installation should be at most a few clicks. Documentation should just be all there, and whenever you have a problem, there's a fairly easy place to go and look. The common use cases, and certainly the example code, it should just work. No no dicking around, no extra steps, and certainly bug-free. And then the second thing is about having the user has to have, or in apps, users need to have a really good mental model of how the app works. It doesn't have to actually be implemented like that, but they have to have a sort of a way of thinking about, oh, if I press this, then I'm fairly sure that this is going to happen or that's going to happen. And you need that to be consistent. And so it is with frameworks and developer UX. So it's reinforced by things like clean APIs. And going back to that fair play rule, where you're implementing all your functionality internally for to do the job that you want to do, then you're exposing just enough or enough to do whatever the plugin developer wants to do. And I mean, we can see this in the Twitter API. This is a really, really nice API. I mean, forget all the politics that go around Twitter itself and their terms of service, but their single-page web app, whatever you think about that, and hash bangs and all that sort of thing, their single-page web app is built with the API that they give to everybody else. So it's completely possible for you to go off and build a competing Twitter service or competing Twitter web page which uses the Twitter API, because that's exactly what they've done. And I think I've talked about the mental model not necessarily having any relation to how the implementation actually works. I mean, the classic example I think about with this particular point would be where you've got a compiler and it takes language and spits out another language. Now, until you learn about compilers, that thing's magic. But you have a mental model of that keyword means something that I know what it means. I know what that keyword does. But before I knew about compilers, I found this whole idea of these keywords sort of magically transforming into behavior really, really difficult to sort of get my head around. But it was my mental model. I knew what was going on, and magic happened in between me typing it and the actual behavior. And finally, a non-leaky abstraction. So Joel Spolsky goes on about leaky abstractions. So you can, it's roughly stating what we've just said, but the leakiness is really refers to how abstractions are never quite complete. And if you can get the leaks to be in places where developers don't normally look, then that makes it a much stronger candidate for being a good mental model. And I talk about here, so it's in the same sort of realm, API usability, and you're designing APIs for developers to use, and I mean, speak to developers, find out what they want, find out what they're going to be using it for, find out where competing tools have failed so badly. And this BDD, I say there, is behavioral driven design, which is where you're sort of looking from the top down. In sort of user, when you're building apps, it's you look at a feature and you draw the interface out, and then you get everything running straight down to the APIs, the server APIs. And yeah, speak to them, show them prototypes, get their feedback, take that feedback seriously, and try and sort of get an iteration going. And yeah, I talk about prototyping there, and it's kind of related to paper prototyping. You want quick, cheap prototypes that you don't get attached to the code which is implementing it. And it's related to a couple of things which I've seen recently, which is where you write the README first, and you write the sort of the tutorial on how to do things before you actually implement the damn thing, and that sort of allows you to focus on what's going to be nice and actually helps you write documentation actually. And then I've seen another thing which is commit log driven development, which is exactly the same. I'm not sure whether I am so enthusiastic about commit log driven development, because you end up with sort of very strange commit logs, which almost sound aspirational and don't have the detail of, oh, I fixed this horrible bug and it was great that I fixed it, well done me. Okay, so I've spent about 40 minutes talking about 3 separate things. So those things, oh my God, I mean, this isn't, I'm really enthusiastic about this because it's just made such a difference to my life and my career, and it's kind of brought me to where I am right now. So language is important. Use the words in your code. Write, read. Reading, blimey, reading code. Read other people's code. Get involved in open source, and that will improve. But that's less important. Or no, it is important, but it's not what I'm talking about now, which is when actually writing code. So break things down. Think about the design and then break that design down into a language which you can reason about, and then write your code in terms of that language. So, and then build in extensibility, even if you haven't got a plug-in system, and do that really early on. And I mean, I've seen this so many times, that you have this really cool concept and, oh, it's not quite ready because we haven't got a way of extending it, and we've seen demos yesterday, which this is exactly, which sort of up until you've got that extensibility, it's a proof of concept or a prototype, and then once you've got that extensibility, it's no longer a proof of concept, it's a product. And finally, this bit about developer experience and user experience. So I'm going to finish almost there. I've just got a couple of things to do. Let me just do a quick gauge. I should have done this in the morning, earlier on. But okay, we've all heard of patterns. How many people have implemented 5 patterns or more? Oh, this is good. 3 patterns or more. Or 3, yeah, okay. And 1 pattern only. You guys rock. So I don't need to tell you about these things. Design patterns, good website. You don't have to buy the patterns book. Effective Java, that's all about APIs, and it's worth reading. All these things are worth reading, even if you haven't. This is slightly less code related. Principles of Newspeak, which is the appendix in 1984. I read it every couple of years, and it blows my mind every time I read it. Growing a language it's an amazing talk by Guy Steele. He's the co-drafter of the Java spec. So if James Gosling is the father, he's probably the filthy uncle. But no, I mean that talk is just so clever, and it's one of those, oh my God, I see what you're doing there. That's an amazing thing. And it's the only talk I've ever heard of that needed debugging. So I don't want to spoil it, but go and have a look at that. The Art of War, just read that. That's amazing too. And it's applicable. You'll find out. And this last one, which is Unwritten Rules of Engineering. It's the sort of thing that you'd really like to have been handed when you were just coming out of college. but you can read it and still learn, even with your seniority. Podcasts, this is up to you. So I'm going to leave it there. I'm just going to say thank you very much. So normally I say questions, but I think it's been quite discursive, so if you want to continue the discussion, who wants to speak?
James, could you give us some examples of some frameworks or toolkits which you think are well designed, and sort of talk through why with some examples? I know you didn't want to get into code, but I thought some examples might be useful for us.
Sure, okay. That's a good question. Well, I would say okay. So, you wanted frameworks rather than plugins? Yeah. Okay. Okay. So I've got this this slide which I think OSGI gets a bad rap, and it's feeling a little bit out of date now because it doesn't use generics. But it's every time anybody comes up with, we're going to modularize the JVM, the OSGI crowd go, oh, why don't you use OSGI? And the Jigsaw people, which is the current Oracle or Sun spec, JS R277, say, oh no, we're going to build our own. And then they go away, and 2 or 3 years later they come back and go, oh, it's really hard, isn't it? And then the OSGI guys go, yeah, it was really hard. We did it, in 100K. It's amazing. So that's something which I've learnt a lot from, and I think it's really nicely designed. What else? From what I've seen of something like jQuery, that seems to have a really nice, clean interface. And it's got plugins, and it's got a nice API, and it's got this monadic stringing together of things, which you can. It feels quite fluent. So I'd probably point to that. What else would I say? On the sort of library or toolkit side, I'd probably want to point out something like Guava, or which helps dealing with collections in Java quite a lot. And actually, the Java util concurrent package is really nice. And if you're still using synchronized keywords and trying to use monitors and keep everything in your head at once, just forget about that. Go and use locks and reentrant locks and countdown latches and semaphores as actual objects. Really, really, really simple, very well designed APIs. And then switching languages again, I would say something like Scala, which has this thing called actors, which again is concurrency, and sort of has this model of you hand a task to an actor, and then that actor does that task in a very type-safe and memory-safe way. And it doesn't really matter what thread that actor is running on. It could be running on one or multiple threads, but you don't have to care. So that's a nice library. So, are there any? Does that answer your question, Arvind? Cool. Okay. Anybody else? Hi.
Have you seen how how some of these patterns apply to non-object-oriented languages, JavaScript, for example? Like, do you have some examples of writing good JavaScript code?
JavaScript's a really interesting language. It's undergone the pain of premature standardization. and so you get all this crappy stuff, you know, function variable scope, and just weird ass warts like the argument stuff. How do we write JavaScript well? I'm a big fan of the way Node does things. And server-side JavaScript came up with this idea of modules. CommonJS CommonJS modules was the standardization of it, which is where you, and if any of you know about JavaScript, it has this this global scope where you write your program and you load all the files together, and it all gets just wound into the same global scope, which means that you can have a file which may be written by you, may not be, but it tramples on variables which that you've written in a completely different file, and that means that, I mean, that's that business of load ordering which I was talking about earlier on, and so it depends on who got loaded first or last, in fact, who gets the variable, and that's really problematic. But the way CommonJS modules work is that it's your file, you do whatever you want in that, and it doesn't interfere with whatever goes on in somebody else's file. So I'd look at sort of CommonJS modules and require.js, which is the asynchronous version of loading that. I'm trying to think. I mentioned jQuery, and I didn't mention Zepto as well, which is the WebKit only version, which almost speaks to the power of jQuery in its APIs, that an API compatible implementation of it, which doesn't do all the cross-browser stuff, you can just whack into PhoneGap or wherever.